Two triangles ABC and LMN in the figure are vertical cross sections through the center of gravity of two identical smooth uniform wedges X and Y respectively, with angle ACB and angle LNM is equal pi by 3 and angle ABC is equal angle LMN is equal pi by 2, such that the faces containing BC and MN are placed on a smooth horizontal floor. The wedge X of mass 3m is free to move on the floor and the wedge Y is kept fixed. The lines AC and LM. The line AC and LM are the lines of greatest slope of the relevant faces. Two ends of a light inextensible string passing over two smooth small pulleys fixed at A and L are attached to particles P and Q of mass m and 2m respectively. At the initial position, the particles P and Q are held on AC and LM respectively such that AP is equal AL is equal LQ is equal A, and the string taut as in the figure. The system is released from rest. Obtain equation sufficient to determine the time taken by X to reach Y in terms of A and G. Answer for this question: two wedges. This wedge ABC is movable and wedge LMN is fixed. This angle 60 degree, this is 60 degree, this one 90 degree, this one 90 degree. Two pulleys here, A and L, and one of the string passing over A and L, and at this end particle P and here particle Q. At initial, this distance A, this is A and this is A. Now observe the motion. When the particle is released from rest, the motion will be shown. This wedge moving to Y, this particle down, here also down. Particle moving down relative to this wedge, this also moving down. Acceleration of wedge X relative to Earth. AXE is equal F. Let acceleration of X relative to Earth is equal capital F, horizontal direction, here F. Acceleration of P relative to X, this particle, acceleration relative to this wedge, F, along this inclined plane. Theory of relative acceleration. APE is equal APX plus AXE. This acceleration of P relative to Earth is equal acceleration of P relative to X plus acceleration of X relative to Earth. APX, this one, in this direction A with horizontal 60 degree plus AXE, this one, capital F horizontal direction, this one. This is the acceleration of P relative to Earth. Acceleration of Q relative to Earth, this one. Because this is an inextensible string, therefore both particles' accelerations are same relative to the wedge. Therefore, acceleration of Q relative to Earth in this direction also M, which the Y is fixed. Weight of wedge X, this one 3 mg, vertically downward. Weight of particle P, this one, mg, vertically downward. Weight of particle Q, 2 mg, vertically downward. This is the R0 reaction on wedge P. Reaction R0. Tension on the string. All portion of the string have a same tension. Here T, here T, here T, here also T, here T, and here also put T. Reaction on particle P, reaction on particle P is equal R in this direction, perpendicular to this inclined plane. Equal and opposite reaction are in this direction. Reaction on particle Q is perpendicular to this direction. Equal and opposite reaction in this direction is. Now we use Newton's second law, F is equal ma, for wedge and particle P for this portion. For this one. What is the resultant force in horizontal direction? This mg, 3 mg won't come to perpendicular direction. This R0 not coming. This R0, this R and this R won't come because equal to each other. This P won't come. This T and this T is balanced. Therefore, this T is the resultant in horizontal direction. T is equal mass into acceleration. 3m. 3m is the mass of the wedge. 3m into this acceleration horizontal direction, capital F, plus in this particle mass m and acceleration of this particle horizontal direction, in the horizontal direction, F minus F cos 60. capital F minus F cos 60. Therefore, T is equal 3mf plus mf 4mf minus mf by 2 cos 60 is a half. For the particle P, we are going to use Newton's second law for the particle P. Along the inclined plane, therefore resultant force, components of mg, this 60 degree, mg cos 60, or therefore this one mg sin 60 or mg cos 30. mg cos 30 minus t. This is equal m into acceleration F minus F cos 60. Root 3 mg by 2 minus t is equal mf minus m capital F by 2. Therefore, capital T is equal mf by 2 minus mf plus root 3 mg by 2. So, particle Q, Newton's second law, along this inclined plane, resultant force 2 mg cos 30 minus t is equal mass 2m into acceleration m, because this wedge not moving, so m. Therefore, when we simplify, t is equal root 3 mg minus 2 mf. Let time taken to x to reach y is t. This wedge is moving. This wedge is moving and reach y. Let this time is simple t. When we use s is equal to t plus half at squared, for the wedge in horizontal direction, this distance is a. At initial, this distance at initial position, the distance between two wedges a. Therefore, a is equal, and the wedge also start from 0 velocity, therefore 0 plus half ft squared. Therefore, t squared is equal to a over f. Therefore, we got some following equation. Capital T is equal 4mf minus mf by 2. Capital T is equal mf by 2 minus mf plus root 3 mg by 2. Capital T is equal root 3 mg minus 2 mf. Small t is equal to a over f. Therefore, these equations are sufficient to find out the time t.